My name is Brandon Howell. I handle technical marketing with Intersil, and I'm here to introduce the ZL8801. The ZL8801 is a two-phase, fully digital power controller. It's part of our fourth generation of fully digital controllers and uses ChargeMode control. Here's a block diagram of the ZL8801. The 8801, as I mentioned, is a two-phase controller. It has PWM outputs for driving power stages. In this case, I'm showing the ZL8801, our latest 40 amp power stage. Going over some of the major features of the ZL8801, we have a V-drive output for providing 5 volt bias to the power stage, PWM output for driving the power stage, direct voltage feedback. All the compensation is done internally using our ChargeMode control, and a PM bus interface for configuration, control, and telemetry. For telemetry, you can measure the input voltage, the input current, the output voltage, the output current, the duty cycle, the temperature, as well as configure the device. The ZL8801 supports current share. With current share configurations, you can have up to 4 controllers for up to an 8-phase design. Current share is handled via our proprietary DDC bus, and we'll go over that in details in a later video. Now let's head to the lab and look at one of the ZL8801 eval boards and our Power Navigator software. So here I've got both the 2-phase and the 4-phase board. The 2-phase board is here in green, the 4-phase board is here in red. As I mentioned, we're going to focus on the 2-phase board for this video, and we can catch up on the 4-phase board in a separate video. Walking through the major aspects of the 2-phase board, I've got the ZL8800 controller in the center of the board. I've got my Dr. Moss power stages, in this case ISL99140, my output inductors, my output capacitors. I've got input terminals for my input voltage, output terminals for my output voltage, and I have a USB to PM bus adapter. This allows us to communicate with the ZL8801 via the PM bus interface and our Power Navigator software, which runs on our Windows GUI. As you can see from the eval board, the controller itself does not require very many external components. We have some decoupling capacitors, there's a couple resistors to set the PM bus address and the output voltage, but that's really it. Because we're a fully digital solution, all the compensation and all the parameters are set inside the device. So because of that, we have a very limited number of external components, very simple 2-phase design, yet it's high performance and very easy to adjust. So now let's connect this board to our Power Navigator software, and we'll look at the telemetry, look at margining, and basic device operation. Now let's launch Power Navigator and interface with the ZL8801 eval board. So when Power Navigator first comes up, it'll automatically scan for any eval boards connected to the computer. It found the ZL8801 eval board at address 30. So I'm going to go ahead and click Start. And then as soon as I click Start, the computer will automatically connect to the eval board. The software automatically downloads all the settings. And now we are connected to the ZL8801 eval board. So in the center part of the screen, I have the power map, which shows the actual ZL8801 board. And then on the Monitor View tab, I've got all the telemetry. So I'm reading the output voltage, the output current, the input voltage, the driver voltage, the temperature, duty cycle, switching frequency, all in real time. So I have the eval board configured for a 12 volt in to 1.2 volt output. I'm going to go ahead and turn on the output. As soon as I do, the output voltage now reads 1.2 volts. I've got no load on the output, so the output current is approximately 0 volts. And I'm still reading the input voltage and the voltage monitor. Now I have the eval board connected to electronic load, and with the load I can put a load on the output. So I'm going to go ahead and load down the output. I just added a 22 amp load to the output, and as you can see, the Power Navigator software is reading back 22 amps. The output voltage remains constant at 1.2 volts. Using our software, I can also change the output voltage. For example, I can margin up and I can margin down. If I do that, I will now margin high. So I margined high to 1.4 volts, go back to standard 1.2 volts, and then I can margin low, and I'll margin low down to 1 volt. So as you can see, evaluating the ZL8801 eval board with our Power Navigator software is very easy. Using the software, you can look at the input voltage, the output current, the supply temperature, basically all the telemetry in real time. When it comes time to build your own system, the same software can be used to interface with your actual ZL8801 design. For eval boards, please see Intersil.com. And again, we have the ZL8801 2-phase board and a 4-phase board as well.